This video will review the exterior angle theorem. To begin, let's start by defining what an exterior angle is. An exterior angle is the angle formed by extending one side of a triangle and then carrying it to a different side of the triangle. For example, if we took this triangle and extended the bottom side off to the right, the exterior angle would be here. Now actually, triangles can have more than one exterior angle. We could also extend this side and carry it to the next side, or we could extend this side and carry it to the next side. So again, we have three exterior angles here. Now when you have an exterior angle, there's also two other angles that are special that we need to study. We'll call those the remote interior angles. The remote interior angles are the angles that are across the triangle from that exterior angle. Again, remote means away from, as in a remote desert island, so we want the angles that are away from that exterior angle. They cannot be adjacent to it. In this case, I've marked them R1 and R2. Now you have to be careful. Where the remote interior angles are depends on what exterior angle you're looking at. So if instead we were looking at the exterior angle formed here, these would no longer be the remote interior angles. R1 is still across from the new exterior angle. However, the second remote interior angle would be over here. So again, you've got to be careful on your figure. You need to look at where the exterior angle is and then which two interior angles are away from it, or the remote interior angles. Now we're going to look at a couple examples to understand what are exterior angles and what are not before we look at the theorem that comes from this. So these 5 examples all show exterior angles. These are angles formed by extending one side and then carrying to a different side of the triangle. However, these 3 are not exterior angles. Take a moment and look at them and see if you can figure out why they would not be exterior angles. For example, the one in the upper right hand corner is not an exterior angle because in this case, this ray right here is not formed by extending any of the sides. If we were to extend this side, it should actually go this way. Or if we were to extend the left-hand side, it would carry up that way. And that's not what we have here, so that's not an exterior angle. The middle example is also a nice one to look at because this time the sides are extended. However, if we extend the side, the exterior angle would actually have to go to the other side of the triangle, not to an extension of one of the other sides. So for instance, what happened here is somebody extended this and that, and then this angle here would not be an exterior angle because it does not go back to one of the original sides. Alright, now that we understand what is an exterior angle and what is not, let's look at the theorem that derives between the relationship of the exterior angle and the two remote interior angles. We're going to call this the exterior angle theorem. And it basically holds this. If you have an exterior angle, then the exterior angle will always equal the sum of the two remote interior angles. Okay, that means, in this case, the exterior angle, angle BCD, would equal the measures of the two angles that are away from that angle, which would be angle CAB and angle CBA. Now another way to say that would be the measure of angle BCD, the angle on the outside, equals the sum of the measures of angles B and A. Now this is useful. If we know the two remote interior angles and we want to find the exterior angle, we can do it simply by saying the exterior angle theorem. That outside angle equals the sum of those two remote interior angles. And we're going to look at a couple examples of how this can be done. Alright, let's take a look at 2 examples here. In the first figure, I see that the measure of angle BCD, or exterior angle, is 56 degrees. And I see the measure of angle CBA, or angle B, is 20 degrees. And we want to find the measure of angle BAC, or angle A, which is measured x. We're going to use the exterior angle theorem to do this. We have the exterior angle, and we know one of the remote interior angles, and we want to find the other one. So in this case, you got to understand x is not always going to be the exterior angle. It can be any of the 3 pieces. It could be either of the remote interior angles or the exterior angle. So in this case, I'm going to say, by exterior angle theorem, the measure of angle BCD equals the sum of the measures of angle CBA plus the measure of angle BAC. Now substituting what I know, the 56-degree angle is the measure of angle BCD. So 56 equals, the measure of angle CBA is 20, and the measure of angle BAC is x. So this is going to be a really quick equation to solve. All we need to do is subtract 20 from both sides, and we find that the measure of that angle is 36 degrees. Now there would have been other ways to do that. You could also have done a linear pair from the 56 degrees and found the angle that is adjacent to it, which would be angle BCA. And then in triangle sum theorem, to find the missing angle. However, that would be twice as many steps as using the exterior angle theorem. So this is a nice theorem to know because it can speed your work up. Now in the second example, x is no longer a remote interior angle. Instead, x is the exterior angle. So for this problem, I'm looking at the exterior angle, and I know the two remote interior angles. So in this case, I'm going to say by the exterior angle theorem, the measure of angle DCB equals the measure of angle CBA plus the measure of angle BAC. Substituting in what I know, the exterior angle is x, and the two remote interior angles are 55 and 27. So if we put it together, we get this equation. Now in this case, all we have to do is add the 27 and the 55, and we find that the measure of that exterior angle is 82 degrees. Now I'm going to put two more examples up, and I want you to try them. So let's look at them. Go ahead, pause the program, work these two examples out, and when you're ready, check your work. I'll give you a minute to try it. All right, hopefully you paused it and tried it on your own. All right, taking a look at on the first example here, that I see that we have a remote interior angle of 33 degrees. The exterior angle is x, but I don't have another number. However, you need to remember that that right angle over at angle A is 90 degrees. It's denoted by the box. So in this case, I know that the remote exterior angle x would equal the sum of 33 and 90. Now to justify it, we'll say it's exterior angle theorem, and we'll identify the angles we're using. In this case, the measure of angle DCB equals the sum of angles CBA and BAC. Substituting, x equals the sum of 33 plus 90, which is 123 degrees. In the other example, we know the exterior angle. Instead, we're missing one of the remote interior angles. So in this case, again, the measure of angle BCD equals the sum of the measures of angle CBA plus BAC by exterior angle theorem. But this time it's the exterior angle that's 136 degrees, and it's equal to 21 plus x. Subtracting 21 from both sides, we find this time that the remote interior angle is 115 degrees. So the big takeaways here, you have to have an exterior angle, again, which is formed by extending one side of the triangle to a different side. And then you can use exterior angle not always just to find the exterior angle, but you can also use it to find one of the remote interior angles. So depending on what piece you know, x could be the exterior angle or one of the remote interior angles, but it's still exterior angle theorem. All right, thank you for watching, and I hope this video helps you to understand the exterior angle theorem.